Metric prefixes. This is how you do it. Our class syllabus will comprise of introduction to base quantities, importance of those base quantities, and conversion of prefixes. Now, when we talk about base quantities, the International System of Units, known as SI units, has dictated its specific unit for each base quantity. For length, it's meters, using M. For mass, it's kilogram, using kilograms, kg. For time, using seconds, S. Temperature, kelvins, a capital K, and electric current, ampere, a capital A. Now, importances. The SI units is for the consistency of measurement. When you're measuring in a country and you want to communicate with another scientist or another person from another country, we use SI units. For instance, in some countries we use degrees Celsius, and in other countries, like America, they use degrees Fahrenheit. Of course, these units are entirely different. 30 degrees Celsius could be around 80 to 90. I'm not sure about the conversion because I don't live in those countries. But how do these countries communicate? They will both each have to convert to kelvins, because Kelvin is an SI unit, which can be understood by all countries because every country will have to learn these units. And once they convert their own units to the kelvins, people from foreign countries will be able to convert that Kelvin temperature into their own personal temperature, and they'll be able to know. Second, it allows accurate exchange of data and scientific knowledge, which leads back to what I just said as an example. Now, the prefix table. We use this prefix table if the value is too big or too small. Examples of these prefixes would be giga, mega, kilo, deci, centi, milli, micro, and nano. And they are represented by these symbols: G, a capital M, K, D, C, M. And this is a weird looking U, but it's actually an M. Now, the values are actually on this column, and the standard forms are actually on this column. The standard forms just mean the forms in indices, where the number of zeros has been summarized to the powers. Like for example, giga has 9 zeros, hence 10 to the power of 9. Now we can use our knowledge of standard forms or algebra to actually understand this topic. For example, let's look at kilo. Kilo is 1,000 or 10 power 3 represented by the symbol K. This is important because my very next example, I'm going to touch about this. Now, if we were to use algebra, using basic understanding, we know that 1 kilogram is 1,000 grams. This is a conversion that all of us have memorized or have used or come across when we were still in school, maybe in elementary or primary. If we cancel the units, we find that the G's are gone and 1K is 1,000. Sure enough, this is true on our prefix table where it says kilo is 1,000 or 10 power 3 represented by the symbol K. Now, using standard form, we will try to convert 1 kilograms to grams. I'm going to break that down into its index form, where it's 1 times K times G. Now, I have that K highlighted in red because I'm going to make a change to it, and this is very crucial. I want you to notice this. I know that K is just a symbol, and its value is 1,000 or 10 power 3. Therefore, I'm going to replace that K with a 10 power 3. And in the next row, I'm going to expand the 10 power 3 and it's going to be 1,000. And what I'm going to do next, I'm going to multiply 1 by 1,000 by grams. And that's going to give me 1,000 grams. Now, why do we learn something even more complicated than we already know? It's actually not. Imagine you're converting from kilograms to milligrams. 1 kilogram is actually 1 times 10 power 3 grams. And then 1 times 10 power 3 divided by 10 power 3 milligrams. Now, where did this come from? This red highlighted second object that I placed. I will explain this in the next slide. And then when we divide by a negative power, we actually multiply by a positive power. And in following the index law, the powers will add when we multiply indices. So it's going to be a 10 power 6 milligrams, and it's going to be a million milligrams. Now, let me explain what I just meant. When we're converting 1 kilograms to milligrams, I took out the K and I replaced with a 10 power 3. Let me explain this part. Let's say we have 1 plus 4. We know that equals 5. And 2 plus 3, we know that equals 5. We are going to use this logic to actually form this equation. 1 plus 4 equals to 2 plus 3. And if you were to look at it, you know that this is true because the left-hand side equals the right-hand side. 1 plus 4 is 5, and the other side, 2 plus 3, is also 5. Since kilo equals 10 power 3 or 1,000, I can actually switch that kilo with 10 power 3 because it just means the same thing. There. Now, the next line, I divided and I multiplied by that m. Where did this come out? Again, I'm going to use the same understanding. 1 plus 4 equals to 2 plus 3. And I'm going to plus 1 on the right-hand side. As you know, this is already a wrong equation because on the left-hand side, I have 5. And on the right-hand side, I have 2 plus 3 plus 1, which is 6. What I can do through this equation to make it true is to minus 1 with it. So now both sides are going to be true. 1 plus 4 is 5. This side on the right, it's going to be 2 plus 3 plus 1 and minus 1. And this side is going to be 5 as well. Now let's look at it in terms of equations. I have an equation here equaling to another equation. What I'm going to do is I'm going to divide by milli and multiply by milli. Because I can do that. It doesn't change anything. And I'm going to replace the milli with the value that milli holds, which is 10 power negative 3 on the prefix table. And that is why I'm going to use the 1 times 10 power 3, which is my kilo, divided by the milli, and I'm going to multiply another milligrams. So this is my special unit that I added, because I want to force that milli into the equation. That is why I have to multiply and divide at the same time. But I'm actually dividing the 10 power negative 3, which is actually represented by the symbol m, milli. Now, the next line. I just replaced these two. Okay. Now, the next line, because we're dividing by a negative power, it's going to be multiplying by a positive power. And when two positive indices multiply each other, it's going to be plus. So it's going to be 1 times 10 powered 6 milligrams. Or a million milligrams. Now, let's see the work without. Let's say we want to convert 1 kilogram. You know what? No. Let's convert 1 kilometer, because this is a unit that we are more familiar with. And we want to convert it to meters. It's going to be 1,000 meters. And we want to convert it to centimeters. You know, it's going to be, you're going to times another 100, so it's going to be 100,000 centimeters. And it's going to be a million millimeters. You might say this is way quicker and even simpler because you know this by heart. You've memorized this formula. But what if we want to convert it to nanometers or picometers? We will still need the prefix table anyway, in any sense, for harder conversions or conversions involving units that you're not familiar with. Now, let's look at other solving methods. Method 1. Let's say we're converting 0.18 kilograms. Okay, we want to convert this to grams. We can either put this in the standard form, which is 1.8 times 10 power negative 1, or 18 times 10 power negative 2. Both these numbers are in kilograms. I'll put a link to the index video in the description below. Now, I'm going to change that kilo to a 10 power 3. Same drill. I'm just going to change the kilo to its value. So that way I can get rid of the K. Now, what I'm going to do next is I'm going to multiply the indices. It's going to be a negative 1 with a 3. And because it's times, the negative 1 is going to plus the 3 and leave me with 10 power 2. Now, whenever we're multiplying by a 10 powered anything, when it's a positive number, we're going to move to the right. This is what I mean. The decimal point is going to move one space, and it's going to be 18 now. But because my power is raised to the 2, I'm going to move twice. So another time, and the decimal point is going to be here. And then because I've moved twice, instead of being 18, it will be 180 grams. And done. The 10 power 2 will be gone. Or if you want the other method, you don't have to convert to the standard form. All you want to do is just keep the original form of that number. And then because this is 10 power 3, what we're going to do is we're going to move to the right 3 times. If it's a negative power, we're going to move to the left. But because now it's a positive power, we're going to move to the right. So I'm going to move once, it's going to be 1.8 now. I'm going to move the second time, it's going to be 18. And I have to move the third time because it's power 3. And ta-da, I have 180 degrees. Sorry, my mistake, 180 grams. Now, some random conversions. Let's say we're trying to convert 0.18 milligrams to micrometers. Oh, my mistake, I should have made this grams. It doesn't matter, we're just converting from milli to micro. That's the main point. So, let's say we have 0.18 milligrams. Sorry, megagrams. This is a capital M. This is a mega, so even I get confused, you guys have to be careful too. Mega on the prefix table, we know is 10 powered 6. So, what I'm going to do is I'm just going to switch the M with the 10 powered 6. So it's going to now be 0.18 times 10 powered 6 grams. That way, I've gotten rid of the mega. Now, without expanding this, because it's going to be a lot of work if I keep expanding stuff. So I'm going to do everything one shot. My next line would be to add the micro, because that's the unit I want to convert to. So because I multiplied a micro in the equation, I have to divide by the micro's value, which is 10 power negative 6. Because micro is 10 power negative 6. I times a micro, I have to divide a micro. Now, dividing by a negative power would be multiplying by a positive power. It's an index law. So because now we're multiplying two positive integers, their powers will add up, giving me 0.18 times 10 power 12 milligrams. Now it's going to be 0.18 times 10 powered 11 milligrams. The reason is because it's a positive power, so that decimal point is going to move one step to the right, giving me 1.8. This is if you want no decimals, you're gonna have to move one more time, so it's gonna be one more time to the right, the decimal point. So it's gonna be 18 times 10 power 10 micrograms. Now let's look at this question then. I want to convert 1729.23 nanograms into decigrams. So it's gonna be, again, I'm gonna take out the nano. So the value for nano is actually 10 powered negative 9. So I'm gonna just switch that with 10 powered negative 9, which I know from the prefix table. And then what I'm gonna do next is I'm not gonna expand this, but I'm going to directly multiply the deci. Because I've multiplied deci, I have to divide by deci. This is the value for deci, 10 powered negative 1. And because I'm dividing by a negative power, it's gonna be multiplying a positive power. Now, I have 10 powered negative 9 multiplied by a 10 powered 1. So it's going to be negative 9 plus 1, which will give me a negative 8. So I have 1729.23. I'm just omitting the 1. So it's going to be 10 powered negative 8 decigrams. 1729.23 times 10 powered negative 8 decigrams. If we want an example of an answer in two significant figures, I'm going to take the same value and I just want to make it in two significant figures. So what I'm going to do is I'm going to round off this number. It's going to be 1700. I'm going to round up to the nearest two significant figures, so it can be 1700 because these two are significant figures. Now, this answer still gives me 4 significant figures. What I want to do next is I want to get rid of the zeros. So what I'm going to do is I'm going to collect the zeros into a 10 power 2 here. So 2 zeros became a 10 power 2. Like I said, the number of zeros is just represented by the powers. Now I have a 10 power 2 multiplied by a 10 power negative 8. So we know that when we multiply indices, we just add the powers. It would be a 2 minus 8 giving me a negative 6. So it's going to be 17 times 10 power negative 6 decigrams. This is my answer in 2 significant figures. Thank you for watching. Remember to like, share, and subscribe. Goodbye, everyone.